but the top, this P subscript 4 plus oxygen subscript 2 yields, and this is diphosphorus pentoxide. Yes, diphosphorus pentoxide. So notice that I'm leaving a little space. So I put a little line, a little blank for my coefficients to go in front of each of my compounds. Of course, this is our reactant side, and this is our product side. This little arrow in the middle, this arrow, we read this as yields. So we would say this compound plus this compound reacts to yield this compound. Okay. Because the arrow sign, kind of like an equal sign, is sort of like marks off one side of our equation from the other side of our equation, I like to draw a little line that splits the equation in half. So I've got one side of the equation and the other side of the equation. And I am going to write out the elements that I see on this side, P and O. And on this side, I've also got P and O, right? They should have the same elements on both sides, right? I'm also going to count, right? This is why it was important for us to learn how to count the number of atoms of a given element. So I've got 4 phosphoruses, maybe. I'm not sure how you say that plural. All right, and we've got 2 oxygens, right? That's subscript 2, subscript 4 and subscript 2. Over on this side, I've got subscript 2 on my phosphorus, so I've got 2 of them. And I've got a subscript of 5 on my oxygen, so there's 5 of them. Of course, the reaction is not balanced. We can see that right away. Remember my priority list, right, for which ones I want to prioritize balancing is metals, then nonmetals, then oxygen, then hydrogen. So I don't have any metals here. I do have a nonmetal, phosphorus. Oxygen is also a nonmetal, but oxygen I prioritize third. So I am going to work on phosphorus first. I see that I've got 4 on my reactant side, but 2 on my product side. I gotta fix that. And I cannot change this subscript. I can't do that. I can only put a coefficient in front of the compound. So if I've got 2 now, if I put a 2 as the coefficient in front of the compound, well, that's going to change the number of phosphoruses that I have. So I have 2 times the 2 coefficient that's in front of it. I like to cross out the number that I had previously and to write the new count next to it, 4. Some people like to erase it. I don't like to erase just because it gets really messy really quickly. And also it's a little bit easier for me to see my process if I know which number I just came off of. So my phosphoruses are balanced now. I've got 4 on this side and 4 on that side, so that's okay. But my oxygens are still not balanced. So let's deal with those. Oh, wait, hold on. So remember the coefficient in front of a compound is going to affect all of the elements in that compound. So this 2 also applies to this oxygen. I no longer have 5 oxygens on the product side. I have 5 times 2, which is 10. So I go back to my reactant side. All right, I've got an O2, and I can change the coefficient in front of that. Well, there's a coefficient I can put that when I multiply it by 2, it'll give me 10. So it'll match what I have on this side. That coefficient would be 5. 5 times 2 gives me 10 oxygens. And now I'm balanced. This is okay as is. For the purposes of Schoology, it needs you to use every blank, right? So they'll give you this situation here where this is blank, and this is blank. It needs you to fill all of the blanks. So if you have any, once you're finished with, and you have a balanced equation, If you have any blanks left over that are still empty, go ahead and put a 1 in as a placeholder there, right? It's not going to change anything about the number of phosphoruses we have, because I still have P subscript 4 times a 1 would still leave me with 4. So that's okay. Let's do this one next is H2N2 and NH3. All right. Same situation, got my reactants on one side, products on the other. I draw a line where the arrow is in the middle so that I can separate them. I have H and N on this side. I also have H and N on this side. Let's count up what we have so far, or to start rather. So hydrogen, subscript 2, so there's 2 of them. Same thing for the nitrogen, subscript 2. Over on the product side, I have H with a subscript of 3, so there are 3 hydrogens. And the nitrogen doesn't have a subscript, and remember this 3 is on the hydrogen. There's no parentheses around this, so the nitrogen does not have this 3. There's only 1 nitrogen here. My priority is metals, then nonmetals, oxygen, then hydrogen. I don't have any metals here. I do have a nonmetal that's not oxygen or hydrogen, it's nitrogen. So I'm going to deal with balancing it first. All right, I've got 2 nitrogens on reactants and 1 in the products. We can change that by throwing a 2 in front of the nitrogen. Of course, that'll apply to the hydrogen as well. So I'm going to change my counts. I now have 2 nitrogens. And my count on hydrogens is the 3 I already had times the 2 from the coefficient. So that gives me a total of 6 hydrogens. Well, now my nitrogens are balanced. That's good. But my hydrogens aren't balanced. So I've got to go back over to my reactant side. And I'm going to change the coefficient in front of the hydrogen, this H2. And I have to pick a coefficient such that when I multiply the 2 times this coefficient, I'm going to get 6. Well, that coefficient is going to have to be 3, because 3 times 2 will give me 6. I didn't use this blank here, so I'm going to put in a placeholder 1, coefficient 1. The next one I'm going to do is number 20 here. So this one with nickel, chlorine. So this is Cl, right? That's not a C capital I. That's a capital C lowercase l. So this is chlorine. And then same thing over here, that's chlorine. So let me leave my spaces for my coefficients. Okay. Reactants on one side, products on the other. I'm going to list out my elements on both sides. So nickel, chlorine, and oxygen. Same thing over here, nickel, chlorine, and oxygen. Let's take stock of what we have. So we're going to count. Nickel is outside of the parentheses, so it will not be affected by this 2 that's hanging outside of the parentheses. All right, it's not going to be nickel 2, it's just one nickel here. For chlorine, it's inside of the parentheses. It doesn't have a subscript of its own, so there's just 1 inside the parentheses. And then I've got to multiply it by the 2 that's outside of the parentheses, right? So these 2 are affected by this 2 subscript here. So I've got 2 chlorines. And then oxygen, the 3 inside, times the 2 outside the parentheses, the subscript, gives me a total of 6. On the other side of the equation, I've got 1 nickel, right? Just the one, no subscript. I've got chlorine, there's two of them, right? Its subscript is 2. And then same thing for oxygen, it also has a subscript of 2. I prioritize my metals, my nonmetals, then oxygens and hydrogens. As you can see here, the nickels and the chlorines are already balanced. I'm not going to mess with them. I'm just going to mess with the oxygens here. If I start messing with oxygen and it changes the counts of the other elements, then I go back and reprioritize them. But here, actually, if I put, so there's 6 oxygens over here, and there's 2 here in the form of O2. So I need a coefficient that can go in front of O2 such that it times 2 will give me 6. That coefficient is going to be 3. Right? 3 times 2 would give me 6. And now I'm balanced with my count on the other side of the equation. All of the blanks that I didn't use, I'm going to place a 1. One of the single replacements, so this one here, this K with water, so potassium and water yielding potassium hydroxide and molecular hydrogen. I've got my reactants, my reactants on this side, my products on my right-hand side. So I draw a line down the middle where my arrow is. I'm going to list out the elements that I have present. So I just have K, O, and H, K, O, and H. And you can see that hydrogen appears twice, right? This is what I was talking about, which is why I leave my hydrogens for last. Because hydrogen is present in 2 places on the same side of this equation here, right? It's in the potassium hydroxide and it's in this elemental hydrogen, or this molecular hydrogen rather. So I'll deal with hydrogens last. I'm going to start with the let me get my counts first. So let me figure out how many I have. I've got 1 potassium, 2 hydrogens, and 1 oxygen. And on the other side, I have 1 potassium, I've got 1 oxygen, and 3. So here's why I have 3. There's hydrogen 2, so hydrogen subscript 2, there's 2, plus another one over here in the potassium hydroxide. It doesn't have a subscript, so there's just 1 of it. And 1 plus 2 is 3. So my potassiums are balanced, my oxygens are balanced, right? My metal, no nonmetals, and then there's oxygen. So I'm going to start with hydrogen, right? That's what I'm going to prioritize first. And if they change the other counts of my metals and my oxygen, then I'll go and reprioritize those. But for hydrogen, let's start there. The only thing I can change about hydrogen on this side is I can add a coefficient in front. But there's no coefficient that I could put here, no whole number at least, that I could put here to make the count of hydrogens on this side 3. It's just not possible. So instead, I'm just going to put a coefficient of 2. And that's going to change the number of hydrogens from 2 to 2 times 2, which is 4. It's also going to change the count on my oxygen. Right, that coefficient is affecting the whole compound. So now I have 2 oxygens. It looks like I'm making it worse, right? It looks like I'm making it more unbalanced, but we're actually making progress here. Let's keep going. I'm going to go back over to the, product side. All right, and I'm going to prioritize my oxygen. It's unbalanced, so I'm going to try to balance my oxygen. I can do that by placing a 2 in front of the potassium hydroxide. And of course, that 2 is going to affect the entire compound. That's the K, the O, and the H. So all of my counts over here are going to change. My potassium will change to 2. My oxygen will change to 2. And my hydrogens, right, 2 here, and then another 2 over here, That's a total of 4. Hey, we finally got our hydrogens balanced. And my oxygens are balanced too. All right, balancing the potassium here is easy. I've got 2 on my product side. In order to make 2 on my reactant side, I'm just going to take and put a coefficient 2 in front of my potassium. That'll change my count to 2. And now we're balanced. I do have an unused blank, so I'm just going to fill this with a 1. I cannot reduce the ratio of these coefficients, right? It looks like I should be able to because there's a bunch of 2s. There's also a 1 here on the end, right? And that 1 can't be reduced down any further. All right, so this is the simplest ratio. So we're all good to go there. I'm going to show you guys this double displacement reaction, and I'm going to do something special to keep us from having to keep track of all these oxygens. Because look at all the different places where oxygen is on, this is number, let's do 39. Let's do this one here. And look at all the different places where we've got oxygen at. We've got it here, 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 and here. So in literally every compound that is part of the reaction, right? But you might also notice that some of these elements, or these groups of elements rather, look really familiar. You should recognize them from your ion chart, from your polyatomic ion chart. I see a polyatomic ion called NO3, nitrate, here, and I also see it on the other side of the reaction over here, nitrate. I also see phosphate, PO4. Right. So I see phosphate here on the reactant side, and also phosphate over here on the product side. Notice how these groups of elements, right, the NO3, that's always staying together as NO3. And the PO4 is always staying together as PO4. We can use that to simplify how we're going to do our balancing. So let me rewrite this on this page here. So we've got silver, I want to say this is silver 1? It doesn't really matter. This is silver nitrate and potassium phosphate, K3PO4, yields Ag silver PO4 phosphate and potassium nitrate, KNO3. I've got my reactants, my products. I'm going to draw a line down the center. And I'm going to take note of which elements that I have, elements and groups of elements. All right, for this one here, once again, point it out again, I'm going to highlight. I've got my nitrate here and here. And I've got my phosphate here and here. So when it comes to listing out the elements that I have present, I'm going to keep nitrate all as one unit and phosphate all as one unit. I'm going to count them all together. So when it comes to which elements, right, elements or groups of elements that I have present, I have silver, I have nitrate, NO3. We're going to count it all as one big unit. I've got potassium here, and I've got PO4, phosphate. Right, going to keep it as one unit. Same thing on the other side, Ag, NO3. And we're going to count how many we have. So on this side, I've got one silver. I've got one whole unit of nitrate. I'm going to keep it all together and consider this to be 1. For my potassium K, there's 3. It's got its little subscript 3. And for the phosphate, same thing with the nitrate, right? I'm going to keep this all together and consider it one whole unit. So there's 1 phosphate. This is a lot simpler than us listing out silver, nitrogen, oxygen, potassium, phosphate. right? There would be a lot of things to list and a lot of oxygens to count. This simplifies that a lot. Anything on the other side? So I've got 3 silvers, it's subscript. Nitrate, I've got 1 whole unit of it. Potassium, there's 1. And I've got 1 whole unit of phosphate. I prioritize my metals, then nonmetals, my oxygens, then hydrogens. Okay, so I'll work on the silver and the phosphate, or not phosphate rather, potassium, right? The K is for potassium. So I'll work on silvers and potassiums first because we can see that those are unbalanced, 1 and 3 and 3 and 1. It doesn't matter which one I start with. I'll start with silver though because it's at the beginning. And I'm going to put a 3 coefficient in front of that silver nitrate. That'll of course change my number of silvers and it'll change my number of nitrates. All right, once again, I'm treating the nitrate as a whole unit. Let me go back over to this side because now my silvers are okay. My potassiums are unbalanced, K. So I'm going to throw a 3 in front of my potassium nitrate on this side. That's going to affect not only the potassium and its count, but also the nitrate, right? This whole unit of nitrate. And that'll make it 3. And that's that. Everything else is balanced. Look at that, right? Nitrates ended up balanced. Our potassiums are balanced. We've got 3 on each side. And our phosphates are balanced. We've got 1 unit of it on either side of our reaction. I'll fill these blanks with 1, coefficient 1. Let me show you guys a combustion reaction actually, because I'll have this other one for you guys to see as well. In this case, for this number 46 here, for this one here, the 1 polyatomic ion that I would keep track of here is phosphate, PO4. And I can see it present in a compound here and a compound here. Okay. But I'll work that one out and I'll have it posted for you guys. I want to do one of these combustion reactions. Let's just do the simplest one. So we'll do 48. Everything's okay. All right, I've got my reactants, my product. I'm going to draw my line down the center. I'm going to list out the elements I have present. Those are carbon, hydrogen, and oxygen. All right, so I'm going to count up. I've got 1 carbon, 4 hydrogens, and 2 oxygens on my reactant side. And on my product side, I've got 1 carbon, I've got 2 hydrogens, and notice I've got oxygen in 2 different places, right? So I've got 1 in my water and 2 as part of my carbon dioxide for a total of 3 oxygens. I find combustion reactions to be the most tedious to balance. That's me. Because there's really no shortcuts about it. It really is just a change and check type of process. But we'll do my best, or I'll do my best with this. My carbons are already balanced, right? So I'm still going to prioritize metals, then nonmetals, oxygens, then hydrogens. My nonmetal carbon is already balanced, so I'm going to go to my oxygen next and try to balance it. Notice that I've got an odd number over here, and that's because I've got this single oxygen. But on this side, on my reactant side, I have an oxygen with a 2 as its subscript. There is no number possible, not a whole number at least, there's no whole number possible that I could place in this blank that would make the number of oxygens on my reactant side to be an odd number. So whatever number I end up choosing, I know that my oxygens are going to have to be evenly numbered. They're going to have to be, just by nature of this having being O sub 2. For now is I'll place a 2 here, and that'll change my count on oxygens to 4. I'm going to go back over to my product side, and I'm going to put a not subscript. Can't add subscripts, right? We don't do that when we're balancing. I'm going to add a coefficient rather in front of my water. The reason I'm going to put it in front of my water, and I'm going to make it 2, is because I want this to be an even number. There's already 2 oxygens here, and if I make this an even number, I can have a total of 4 oxygens. 2 here, and then this 2 is affecting the hydrogen and the oxygen. Okay, well that's all right. Let's keep going. My hydrogens are also going to change in their count, right? I'm going to end up with 2, or 2 times 2 rather. There's already 2 hydrogens, and then I'm going to multiply that by another 2 to give me 4. And it looks like we're balanced now, right? I've still got 1 carbon on either side. My oxygens, I've got 4 here, and I've got 1, 2, 3, 4 here. And then my hydrogens, right? I've got 4 in this CH4. This is called methane. And I've got 4, right? 2 times 2 in my water, right? This is a balanced equation here. Oh, and I'll put in my 1 as placeholder. Cool.